question, 5-2. Yeah, just throw it in there, thank you. So, 5.2, continued. And today, we're going to continue what we were talking about yesterday. We were talking about polynomials of higher degree, right? So instead of it just being a quadratic, which was all of chapter 4, it's higher than that. Well, the first thing I want to talk about is what we call multiplicities. Multiplicities are simply having the same zero solution. Oops, I spelled it correctly. Multiple times. All right. So, for example, when we were doing completing the square, we made perfect squares. So we had this whole x plus 2 squared, which this really means I had x plus 2 times by x plus 2, correct? So in this case, if I set that equal to 0, I get x equals negative 2. But how many of them do I have? There's 2 of them. So when this happens, we're going to say this is a multiplicity, or mult2. Okay? So if I had a parenthesis that says x plus 3 to the 5th power, my 0 for this parenthesis is x equals what? Negative 3. Very good. And it's got a multiplicity. How many of them are there? 5. Alright, so using that idea, the reason this is important is going to go back to what we talked about yesterday a little bit. If you have an odd multiplicity, like we did yesterday, we had all ones yesterday, right? The graph crosses through the x-axis. If you have an even multiplicity, the graph bounces off the x-axis. Okay? So, for example, we'll do an example. Let's say I have y equals x plus 2 squared times by x minus 3. Alright? So this first one, I have a 0 at x equals what? Negative 2. And this has a multiplicity of what? 2, correct? Because that's my exponent. This one is a 0 at positive 3. What's its multiplicity? It's just 1, right? That's what we were doing yesterday. So you don't even have to write multiplicity anything. It's just the 1. Now, on our graph, I have a 0 at negative 2, and I have a 0 at 3. Okay? At 2, it's an even multiplicity, so when I draw it, it's going to bounce off the x-axis and then cross through the other one. Because this is odd, this is even. So anytime it's even, it bounces off. Okay? That's why those multiplicities are important. That tells us a lot of information. Alright? Okay. So here is example number 1 today. Example 1. This is what you have to do for, ready for this? Number 27 through 34. Fat chunk, yes, that's one way to say it. It says find the zeros and their multiplicity. And all but 2 are in this form. Y equals x squared times x minus 1 to the third. Well, let's just stop there. Okay? So all but 2 are in factored form for you already. So you have even less work to do today. So we start with the first one. X equals 0, and it has a multiplicity of what, Carson? Multiplicity 2. Next 0. Hayden. X equals what for this one? 1 with a multiplicity of 3. Perfect. That's it. That's all you have to do. Okay? That's the first section. That's all you have to do for the first section. There are 2 that you have to factor yourself. Just 2. Yes, ma'am. Right. So let me do one more. Yes, but just a second. Okay, yes. So, example number 2, same directions. If I have, for example, y equals x plus 3 squared times x minus 4 to the third times x plus 1. Something like that, Steph? Okay. So we start with the first parenthesis. Set that equal to 0. I get x equals negative 3 with a multiplicity of what? Perfect. Second parenthesis, I get x equals 4. Yeah, multiplicity is 3. The last one I get x equals negative 1. And because it's to the first power, you don't even have to write multiplicity 1. That's it. Okay? All right. You wanted one where we have to factor? Okay. Example number 3. Again, same directions. Let's do y equals, and because you like the box, I'm doing this one. 2x squared. Or sorry, 2x to the third. Let's make that to the third. My bad. 2x to the third. Plus x squared. Minus x. So we have to factor. We take out the greatest common factor first, which is take out an x. Leaves us with 2x squared plus x minus 1. Now we draw our x. Last number times the first, negative 2. Middle number is 1. What are my sides? Two, negative 1. That I agree with. Now, because the leading coefficient is 2, I have to do the what? The box, exactly. So we have 2x squared here. Negative 1 is the last spot in the box. My diagonal, 2x and negative 1x. Out of the top line, I can take a 2 and an x. Out of the bottom line, I can take out negative 1. Up and down, what can I take out? And up and down the last one. Just a 1. All right. So here are my factors. I have 2x minus 1. I have x plus 1. And don't forget that x in front. Now we answer our question. What is the 0 for the first one? X equals what? 0. What's its multiplicity? It's just 1. So do we have to write anything down? What is this 0? X equals? If I set this equal to 0, 2x minus 1 equals 0. Add 1 over 1 half. Is its multiplicity anything but 1? No. And in this last one, what's my 0? Negative 1. And its multiplicity is still 1 too. Okay? All right. So that's the whole first section. I have 4 problems to talk about. Okay? Example number 4. Fine. And this does refer to numbers, sorry, I forgot to tell you, 35 through 38. Find the max and min. We are going to be using our calculator to do so. First of all, we have y equals. Let's go with x to the third plus 4x squared minus 5x. First thing I want you to do is grab that wonderful graphing calculator you have in front of you. Type it into y equals. Type that equation into y equals. The y equals in the upper left. Then hit graph. Yes, please. Yes, please. Okay, so hold on. Let everybody catch up. Okay, if you cannot see it, it should look something like this. Okay? If you cannot see the whole thing, you need to go to zoom and zoom out once. So go to zoom out and hit enter twice. You should be able to see it in a smaller scale. Okay? So once I zoom out, this is actually looks really tiny. And it's looking like this. Really small. Okay? We're still all good? Now, this point right here is called the what? It's the maximum. So that's what we're going to find first. So we're going to go second trace down to the word max and hit enter. What? Hit enter. On your screen it comes up with the word left bound. It should come up as left bound. You move your cursor to the left side of where the maximum is. You got to move it and then hit enter. When you hit enter, it comes up as right bound. So then you move your cursor to the right of it and hit enter. Once you do that, you should have two dotted lines that surround that maximum. And it comes up with the word guess underneath the graph with a question mark. Then you hit enter one more time. Tell your calculator, yes, I want to know it. And then it says maximum. Your x value is negative 3.189. Your y value is 24.193 if you round-ish. That's all you have to do for the last four problems. But now we got to do the minimum. So you got to find the max and the min. Yep, exactly. So now we're going to go back through and do second, trace, go to the minimum, and enter. Excuse me. And you surround the minimum point. So the left bound is on this side. The right bound is on this side. Hit enter, same thing. Okay? You hit enter. Okay? It comes up as left bound, right? Move it to the left of where the minimum is. And hit enter. Then move it to the right of where the minimum is. Hit enter. On guess, you hit enter one more time. And you should have the minimum come up as the 0.522 and negative 1.377. Okay? So, we have 10 plus minutes right now. I highly recommend that we do those last four problems while you are here with me first. Okay? And I'm going to walk around and help you with the calculator. All right? But if I'm going to help you, you're going to listen to me. You're not going to cut me off and try and, if you want my help, then you want my help. Got it?